Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. Today's video is a quick yet comprehensive review of Introductory Python. Whether you're a student brushing up before your next computer science course or an experienced programmer revisiting Python, this video will help refresh your skills. I have a full course in Introductory Python, among other Python courses, that you can watch for a thorough introduction or if you need more detail on any content in this overview. I also have a Python course that teaches Python while writing a text adventure game. I'll include links to those playlists in the description. Put a comment below if you can't find what you're looking for. This is going to be quick, so let's get right into it. This video isn't going to be a lecture so much as a series of examples, upgrading a program with increasingly advanced concepts. We'll begin by creating an input processing output program. I'm running idle, the development environment that comes free with a Python installation. And I'm going to create a new script by choosing New File from the File menu. Note that I have set idle so it will show line numbers, which makes it easier to match errors to error messages and talk about the code. I can do this for an individual script under the Options menu, or for all scripts by choosing Configure Idle from Options and checking the box in the Shell Ed tab. We'll call our first script energydiff.py. I have downloaded a dataset from Our World in Data on energy use per person that I will use for this video. I'll include a link in the description. A note on script names. It's important that you do not give your script a name that is the name of another Python module, because that will hide the other module from your script. Always give each script a unique and specific name. For our first version of this program, we'll prompt the user for a country name, 2 years, and the energy use per person for those years, and we'll calculate the difference in energy use between those 2 years and display it. We'll need variables to store the values the user will enter at our prompts, the inputs to the program. Python is dynamically typed, which means we do not have to declare a variable before we assign a value to it. Let's write the input statement to get the country name from the user. We can get a value from the user with one line of code. Country name equals input. Please enter the country name. The input statement displays the prompt to the user, the text that's in quotes inside parentheses, and waits for the user to type a value. After the user types a value and presses enter, the input statement returns that value. If we want to use that value in our program, and we usually do, we put the input statement to the right of an assignment, and we put a variable name on the left. Whatever the user types will therefore be assigned to our variable. In this example, our variable name is country_name. The convention in Python is to use snake case, or words separated by underscores, for variable names. Variable names may consist of letters, numbers, and the underscore, and they may not begin with a number. By convention, they begin with a lowercase letter, except in special circumstances, and are meaningful. The assignment operator is the equals sign. If I save and run this, I see the prompt in the shell, please enter the country name, and it's waiting for me to type something. I'm going to type United States and press enter. From the user's perspective, that's what an input statement does. From a programmer's perspective, it returned the value United States, and then, because of the assignment statement, that value got stored in the variable country name, or more properly in Python, we say that value was associated with the variable country name. In the shell, I can type that variable name, country name, and see that it evaluates to United States. Notice United States is enclosed in quotes, which tells me the data type is string. String is the name of the data type for text. In Python, the data type is str. In Python, strings must be enclosed in quotes. They can be enclosed in single quotes, double quotes, triple single quotes, or triple double quotes, as long as you're consistent with the beginning and ending type of quote. Everything between the quotes is part of the string, and it is one literal value. The input statement always returns a string. We want to get 4 more values from the user, and they are not text, not strings, 2 years and the energy usage for those years. Years are whole numbers, integers like 1965 and 2015. In Python, that data type is called int. In this data, the energy usage is a real number. It has a decimal part. In programming, we call that a floating point data type, and in Python, that data type is called float. I will write the input statements for the years and energy usage. Year 1 equals int input, what is the first year? And on the next line, year 2 equals int input, what is the second year? On the next line, energy 1 equals float input, what is the energy usage for the first year? And finally, on the next line, energy 2 equals float input, what is the energy usage for the second year? Notice, importantly, that every single line is flush left in the editing window. Indenting them even a single space would cause an error. In Python, program structure is communicated through indentation. I'm going to run our script, and I'll type United States again at the first prompt, and I'll pull some values from the data I downloaded, 1965, 1980, 73,802.305, and 90,281.38. That's kilowatt hours per person, by the way. And if I look at those variables in the shell, I'll type energy 1, we can see it's 73,802.305. And if I look at year 2, it's 1980. Notice that these values are not surrounded by quotes. They are not strings. The year is an int, and the energy usage is a float. In our code, you can see that we surrounded the second and third input statements with int, open, close parentheses, and the fourth and fifth with float, open, close parentheses. The int function converts a string to an integer, provided that string is a string representing an integer. Otherwise, it will not work. So int, open paren, open quote 4, close quote, close paren, will return the integer 4, but int, open paren, open quote, hello, close quote, close paren, will give us a red error message called an exception, and it will halt our program if it happens while a program is running. Similarly, the float function will convert a string to a float, provided that the string is representing a float. In our script, now that we have our values, let's calculate the difference between the energy usage values for the 2 years and tell the user the difference. We'll write diff equals energy 2 minus energy 1. Python recognizes the usual arithmetic operators, plus, minus, divide, which is a forward slash, and multiply, an asterisk, as well as exponentiation, 2 asterisks with no space between them, flooring division, 2 forward slashes with no space between them, and mod, the remainder of an integer division, a percent sign. Here we're using subtraction. There is an operator precedence in any programming language that defines the order in which operations will be performed. For arithmetic in Python, it's the same PEMDAS order you learned for math. At the same level of precedence with multiplication and division are flooring division and mod. As you learn new operators, such as the relational operators and the logical operators, you should consult the operator precedence table to see how these operators fit into the precedence. You can always use parentheses in Python to force the order you want operators to be evaluated in, or simply to make the existing operator precedence clear. Remember, you must always use an asterisk for multiplication. There is no other symbol you can use, and you can't put expressions next to each other or in parentheses next to each other to indicate multiplication. Python won't understand that. When you have expressions separated by a fraction bar, you should put parentheses around the numerator expression and the denominator expression. When there isn't an operator for an expression, such as square root, you should look in the math module for an appropriate function. To display the results, let's begin by concatenating together some output, and then we'll look at a more powerful formatting option. We use the print statement to tell the user something. So print, open parentheses, open quote, in space, close quote, plus country name, plus quote, comma, the difference in energy usage between space, quote, plus str, open paren, year 1, close paren, plus quote, space, and space, quote, plus str, open paren, year 2, close paren, plus quote, space, is space, quote, plus str, open paren, diff, close paren, plus quote, period, quote, close paren. I'm concatenating together literal strings like in and the difference in energy usage between with the values in the variables, the values the user typed, and the value we calculated using the concatenation operator plus. In Python, we cannot concatenate numeric types like int and float together with strings. So we must convert each numeric type to a string before concatenating. That is why we have the str function wrapped around each numeric variable. We can get more control over our output using string formatting. The most common kind of string formatting you'll see in Python now is the f-string, but I'm going to show you the format method first because f-strings have some limitations. It is very easy to convert from the string format method to an f-string, as I'll show you. I'm going to put this print statement directly below the other. Print open quote in open curly brace :s close curly brace, comma, the difference in energy usage between open curly brace :d close curly brace and open curly brace :d close curly brace is open curly brace :0.3f close curly brace period close quote dot format open paren country name comma year 1 comma year 2 comma diff close paren, and I will bring the dot format down to the next line just for readability. With the format method, we put curly braces inside our string where we want to interpolate in or substitute in the value in an expression such as a variable. I have 4 sets of curly braces in my string. Inside them, I have format specifiers. Those start with colon and end with a letter indicating the type of data being substituted in. You can see here we use an S for string, D for integer, and F for float. Between the colon and the letter, we can put other options. The 0.3 indicates we want our output formatted to 3 decimal places. I'll run that with the same input values we used before, and you can see the output looks the same except the float is formatted to 3 decimal places where we used the format method. This is a table from one of my books of some of the optional components of a format specifier in order. You can specify a fill character, which goes along with width. The fill character is what character should fill in the empty parts of a column. Alignment, whether or not to include a sign for a number. Again, width, which will allow you to create output with columns. Including commas to group long numbers, and the precision and type, which we've seen. I'm not going to go into these options in detail, but you can read the Python documentation on the format specifier mini language or watch one of my videos on string formatting in Python. Now let's convert this to an f-string, which is a newer and more common way to format strings in Python. In an f-string, we do not put .format after the string and then list the expressions to be interpolated into the string as the arguments to the format method. Rather, we put an f in front of our string, and then put those expressions directly into the curly braces before the colon. So that reads print, open paren, f, quote, in open curly brace country name :s close curly brace, comma, the difference in energy usage between open curly brace year 1 :d, close curly brace, and open curly brace year 2 :d, close curly brace, is open curly brace diff :0.3f close curly brace period close quote close parentheses. And note, because we're not doing any optional formatting for the string or integers, we don't need the :s or :d. We also didn't need them for the prior formatting. I just wanted to show you those type specifiers. If I run this, you'll see I get the same output for the f-string as I got for the format method. Now, one more thing here. We're going to add proper documentation for this program. We start a program with a docstring. That's a string enclosed in triple quotes at the top of the script. It is not a comment in that Python does not ignore it. The docstring is stored in a variable called __doc__. In the docstring, I'm going to write obtain energy usage per capita data for 2 years for the same country and calculate the difference. You can also include your name and the date and make that docstring as long as you need to describe the program. It is a Python convention to use this imperative language in a docstring as if you're commanding Python to do something. Over each block of code, we should have a single line comment. Single line comments begin with a £, or you might call it a hashtag, and they extend to the end of the line. Over the first block, I'll write obtain country name, years, and energy usage data for 2 years. Over the second, I'll write calculate the difference in energy usage for the 2 years. And over all of our output lines, I'll write display the energy usage difference to the user. Now, there is one other form of documentation we should include, and that's variable annotations. Variable annotations list the variables in a program and their data types. Python will also store the variable annotations in a special double underscore variable called __annotations __. But the annotations are not checked by Python for correctness. There are tools that can check your variable annotations for correctness. A variable annotation looks like variable name, data type. Many beginners commonly confuse a variable annotation with defining a variable. A variable is defined when it appears to the left of an assignment statement. That's when the variable gets a value and comes into existence. A variable annotation is simply documentation. So we'll annotate country name, str, year 1, int, year 2, int, energy 1, float, energy 2, float, and diff, float. We have now successfully created a program that calculates the difference in energy usage per capita for any country and any 2 years. Now, let's take it a step further by introducing conditional logic. For each big change I make, I'm going to create a new script. The code for this video is in my GitHub repository. There's a link in the description. There are also links to exercises which allow you to write parts of each of these programs for practice. You might practice with each concept as we cover it to maximize your learning. I'm going to rename this to energyDiffConditional.py. To customize the program's output based on the calculated difference, we'll use an if statement. If the difference is greater than 0, we'll show an increase message. If less, a decrease. For exact matches, we'll display that the energy usage per capita didn't change. We'll need to write a Boolean expression. Here is a table of the relational operators less than or equal to, greater than or equal to, and not equal to. Note that when there are 2 symbols for one of these operators, such as less than or equal to and not equal to, you must write them in the correct order, and there is no space between them. You can use these operators to compare integers, floats, and strings. The only change from our last program will be the output. Instead of displaying the change to the user, I'm going to check if the calculated difference is above 0, below 0, or equal to 0, and display a different message for each of those conditions. An if statement allows us to execute code only if a Boolean condition evaluates to true. I will write an if statement composed of 3 parts, an if, an elif, and an else. Let's write this statement first and then talk about variations. The syntax is the keyword if, followed by the Boolean condition, in our case diff greater than 0, followed by a colon. Following that, indented, is the code that will execute only if that Boolean condition evaluated to true. I will write a print statement. Print f energy usage between year 1 and year 2 increased by diff.3f kwh. For our next condition, we'll write elif followed by another Boolean expression, diff less than 0, a colon, and indented code that will execute only if that condition is true. Elif is short for else if. For this one, we'll print energy usage between year 1 and year 2 decreased by diff kilowatt hours. And finally, we'll want an else followed by a colon. An else does not have a condition. It executes if all of the conditions before it in the if statement were false, so it's like a default. After else, we'll put energy usage between year 1 and year 2 did not change. This is a series if statement, which we choose if the conditions are mutually exclusive, as they are here. Either diff is less than 0, greater than 0, or equal to 0, the case handled by the else. There are no other options. Now, there are many variations possible. In an if statement, you can have only an if and no other parts. You can have an if and an else with no elifs. You can have an if and one or more elifs with no else. And you can have an if with one or more elifs and an else. What you include depends on the problem you're solving. You cannot have elifs or an else without an if. As I mentioned before, indentation is structure in Python. You must indent code below an if, elif, or else, and that indented code is the code that executes if the condition is true, or if you've reached the else because no other conditions were true. The amount that you indent doesn't matter, as long as you're consistent throughout the entire script. 4 spaces is standard. If you are writing your program in idle, idle will convert a tab to 4 spaces. Fewer spaces might make the structure harder to see, so I recommend using at least 3. You can have as many lines indented under a condition as you need, so although I have only 1 here for each condition, I could have more. As long as they're indented, they're part of the conditionally executed code. Once you include a line of code that is back at the original level of indentation, the same level as the if block is completed. This is a source of many beginner errors, as a beginner might unindent a line of code after an if, but still have an elif or an else. Once the unindented line is reached, the if statement is over, and Python does not allow an elif or an else that isn't part of an if, so you would get a syntax error. In Python, the data type of a Boolean expression like diff greater than 0 is bool. The Boolean literals are true and false, written with uppercase T and F. You will usually only use these literals if you are assigning an initial value to a Boolean variable. Now that we have successfully written a version of our program with customized output based on the results of the calculation, let's take it a step further and introduce logical operators and loops. Suppose we want to write a more complicated expression, one that involves 2 or more conditions. We can use the logical operators and or to join Boolean expressions. In Python, these operators are the words and or, all lowercase. I'm going to demonstrate them with the next version of this program, energy diff whiles. You can use the logical operators in an if statement too. I'm just going to introduce them in the context of a while loop. The logical operators and or each take 2 Boolean expressions as their operands. So the expression to the left evaluates to true or false, and the expression to the right evaluates to true or false. Each expression must be a complete Boolean expression that evaluates to true or false. I'm going to write an input validation loop for the year first. The year should be between 1965 and 2024, the minimum and maximum years in the dataset inclusive. Now here's a picture of a number line. This can be helpful for writing a logical check for a value in or out of a range. For a valid year, year 1, for example, it will be greater than or equal to 1965, and it will be less than or equal to 2024. So the expression is year 1 greater than or equal to 1965, and year 1 less than or equal to 2024. Both of those expressions have to be true for an and to evaluate to true. Here's a truth table for and. The and evaluates to true only when both expressions are true. Here's the truth table for or, and or evaluates to false only when both expressions are false. This is pretty close to how we use these words in natural language. Note also a very common error that beginner programmers make, and that's forgetting to write a complete logical expression on either side of the and or. A common mistake is to write year 1 greater than or equal to 1965 and less than or equal to 2024. That, fortunately, will be a syntax error. But if you write year 1 greater than or equal to 1965 and 2024, that will not be a syntax error, and it is not what you mean to write. Or a similar example is year 1 and year 2 greater than or equal to 2024. That is not a syntax error, and is not checking that both values are greater than 2024. Make sure the expressions on each side of an and or are complete expressions that evaluate to true or false. Back to our number line. A year outside of the valid range will either be less than 1965 or it will be greater than 2024. That expression looks like year 1 less than 1965 or year 1 greater than 2024. Now let's talk about an input validation loop. This is a loop that will execute as long as we have invalid input. We use a conditional loop because the number of times it executes is dependent on a condition, the user giving us bad input. It's not executing a specified number of times. After we obtain year 1 from the user, we write while, and then the condition, year 1 less than 1965 or year 1 greater than 2024, colon. We want to go into the loop when the input is invalid. Then the code we want to execute when that condition is true, indented under the while statement. The difference between an if and a while is that after the indented code is executed with a while, execution will go back up and test the condition again. So we will repeatedly execute that loop body, the indented conditional code, until the condition is false. So I'm going to put indented under the loop header an error message to let the user know what they did wrong, and then the prompt, and I'll obtain the year again. Let's talk about the loop control variable here, the variable that ensures our loop will execute exactly the correct number of times. That variable is year 1. That is the variable that is in our test, year 1 less than 1965 or year 1 greater than 2024. That variable must have a value before we test it. It gets that value on line 16 when we read a value from the user. Informally, we call that the initializer for the loop. And then the value is tested, and if that test is true, we go into the loop. Inside the loop, we must have code that changes the variable being tested so that the loop entry condition will eventually be false and will drop out of the loop. Otherwise, we'll have an infinite loop, a loop that never ends. I call that line of code informally the updater. It updates the loop control variable's value so the loop eventually ends. That line of code is the line inside the loop in which we read the new value for year 1 from the user. All properly written loops will have an initializer, a test, and an updater. On the internet, you'll see loops written with a while true condition, an infinite loop, and then a break statement of some kind inside. I've even seen AIs generate code like that because the AI has been trained on the code on the internet, which is not all robust, readable, error-proof code. Don't write your loops that way. I do have several videos on why not to write loops that way and how to write them properly. I will link one here because it's important. I'll write a similar input validation loop for the second year input. So that condition is year 2 less than 1965 or year 2 greater than 2024. And then the same code inside the loop, an error message and a line of code reading a new value for year 2. Let's write one more loop in this program and then we'll move on to the next version. Let's write a loop that allows the user to enter data for as many countries as they like until they're done. This, again, will be a conditional loop. What we'll do is allow the user to enter a country name or the word done if they don't want to enter any more countries. So the country name variable, country name, will control our loop. We will need an initializer, and that is the line on which we first read the country name. I will change the prompt to read, please enter the country name or done to quit, so the user knows how to finish entering data. And then a test, so while country name is not equal to done. And then indented, I will get the rest of the information for the country and calculate and display the difference. At the end of the loop, I will need an updater so we don't have an infinite loop. I will prompt for and read either the next name or the word done. I will copy and paste my initializer to the end of the loop body, the indented code. If we run that now, the user is able to enter as many year energy usage pairs as they like, and then when they enter done, the loop and the program ends. This is called a sentinel controlled loop because the loop ends when it reaches a sentinel value in the input stream. Here, the sentinel input value is the word done. The sentinel value must be a value that can't naturally occur in the data. Because there are no countries named done, we can use that as a sentinel value. Python also has a counting loop or for loop. A for loop is an excellent choice if you want a loop to execute a fixed number of times, or when you're working with a collection of data that is an iterable, meaning you can use a for loop to visit elements in the collection. We'll look at a for loop a little later in this video when we talk about lists. Before we move on to the next version of this program, let's briefly revisit order of operations. We've learned relational and logical operators, less than or equal to, greater than or equal to, not equal to, and or. The not operator, written out as the word not, all lowercase, negates the value of the logical expression that comes immediately after it. Many languages preserve the PEMDAS order of operations, but once we incorporate relational and logical operators into our expressions, it's important to check the order of operations for the language we're using and use parentheses to clarify or force the order of evaluation that we need. In Python, we have the PEMDAS operators with a high precedence, the arithmetic operators, and then the relational operators have a lower precedence than the arithmetic operators. They all have the same level of precedence, meaning they're evaluated left to right in an expression. And then we have not, followed by and, followed by or. So not has the highest precedence of the logical operators, and has a higher precedence than or, meaning even if or comes first in an expression containing both and or, and will be evaluated first. Our next version of the program is called energydifffunctions.py. In this version of the program, we will take some of the functionality and put it into a function to simplify the loop. First, I'll put everything we have now into a main function. Under my docstring, but before I annotate variables, I'll write def main, open close parentheses, dash, close angle bracket, none, colon. And then I'll select all of the code that's here and press Tab to indent it. The def keyword is how we define a function. That is followed by the function name, parentheses, and a colon. If we want to annotate the return type of the function, we put dash, close angle bracket, like an arrow, and then the data type that the function returns between the arrow and the colon. All code that is indented under the function header is the function body, the code that will execute when we invoke or call the function by using its name. The rules for naming a function are the same as for a variable. You may use letters, numbers, and the underscore, but you must not begin a function name with a number. As always, names should be meaningful, and by convention, they begin with a lowercase letter, except in special cases, and use snake case. This code defines our function, but it doesn't execute it. If we want this code to execute, we'll write main, open close parentheses, at the bottom of our program, at the same indentation level as def. You may have learned to write if underscore underscore name underscore underscore equals equals, quote, underscore underscore main underscore underscore close quote colon, and then indented the call to main. That is proper Python, but I don't usually teach it in an introductory class because it is important in slightly more advanced situations, if there is a chance the script you're writing will be imported as a module. What we have just done, defining all of this code as the function main and invoking or calling it at the bottom of the script, does not change the functionality of the script at all. It is a very good habit to learn, however, and is necessary in the more advanced situation that I just mentioned when your script might be imported into another script. Let's write another function, one that obtains and validates a year. That will simplify the code in main a little bit, and it's a good candidate for a function because we obtain and validate years twice, so it will reduce the repetition. Copying and pasting code is often a source of errors. Above main, I'm going to define a new function, def obtain valid value, valid min, int, comma, valid max, int, comma, prompt, str, close paren, arrow, int, colon. And below that, first, I'm just going to copy the code that obtains year 1 and paste it in, indented under the function header. I'll actually have to dedent it because it's indented too much, once for the function main and once for the while loop. I only want to indent it once. Let's talk first about this function header. Inside the parentheses, I have 3 formal parameters, sometimes called simply parameters. These are the values that come into the function so it can do its job, and usually parameters allow you to write a more general function that is then specialized by the values in the parameters. I have valid min and valid max, which allow me to pass in different minimum and maximum values for the range of valid values. So in my input validation loop, I would change 1965 to valid min and 2024 to valid max. Where I call this, I'll pass in 1965 and 2024. But if I were using a different data set, or for some reason wanted to narrow or change that range, I could pass in different values. And then I also want to specialize it with the prompt parameter. So instead of having input what is the first year, I'll write input prompt. That way I can pass in what is the first year or what is the second year, or a different prompt if I'm using this to obtain a different value. I'm going to change the error message to the value must be between valid min and valid max. That way I'm not assuming this is being used to obtain a year, as the prior error message assumed. I'm just using information passed into the parameters. I'm going to change my variable name. Year 1 worked below when I was obtaining the first year, but here I want a more general variable name, so I'm going to call it value, and I'll annotate that. You can see in the function header that this function returns an integer. That integer is the validated year. At the end of the function, therefore, I'll write return value. Where it is called, this function evaluates to the value it returns. Finally, it's common to put a docstring under a function header which describes what the function does and is returning, if anything. I'll write obtain and return a valid value between valid min and valid max inclusive. Down in main now, I can delete the code that obtains and validates the year and replace it with calls to the new function. So year 1 equals obtain valid value, 1965, 2024, what is the first year? And year 2 equals obtain valid value, 1965, 2024, what is the second year? Parameters are matched by order. So 1965 will get copied to valid min, 2024 will get copied to valid max, And what is the first year will get copied to prompt the first time the function is called, and what is the second year will get copied to prompt the second time the function is called. And each time, the function will return the valid year, so I am assigning that to the year 1 and year 2 variables. When the function is called, down in main, execution jumps up to the function code. The argument values, what we're passing into the parameters, are copied into the parameters. The function executes, and then once a return statement is reached, the function execution ends. If there are no return statements, as in main, the function execution ends when we run out of code. When function execution ends, control returns to the line on which the function was called. If the function returned a value, the function call is basically substituted with that value. So here, because the function call is on the right side of an assignment statement, the function evaluates to whatever validated year the user typed, and the assignment statement then finishes executing, assigning that value to the appropriate year variable. For our next topic, we're going to continue to work with this data, but we're going to write a new program. Because there is a lot of energy usage data, it will be easier to read it from a file rather than prompting the user to enter it. So I'm going to create a new script called energyfromfile.py. This script will work with some data that I've already extracted from our dataset and stored in a text file. You can use any text editor or Excel to create a text file, and your Python script will be able to read from it. Just be sure to save in the plain text format. This is the text file. It's called usa.txt, and here you can see it at the desktop. It is in the same folder with my program energyfromfile.py. That is very important because we're not going to talk about file paths in this video. To read from a file by using the name of the file, as we will do, the file must be in the same directory with the program that's reading it. And you can see usa.txt is composed of 60 floating point values. These represent the energy usage in kilowatt hours per person for the United States from 1965 through 2024, the years available in the data. They are organized one to a line. It is very important that you know and understand the format of your data before you write a script that reads your data. Otherwise, the script won't work. One thing we don't need to know, though, is how many values are in the file. We just need to know the type of data and organization of the data. I will write a docstring at the top, obtain energy usage per capita for a single country over a series of years, report the highest, lowest, and average. So in this program, we're going to not only read the values from the file, but we're going to find the highest and lowest as we read, we're going to total them as we read, and we're going to count them as we read. We'll use the total and count to calculate the average value. This will show you some variable roles that we commonly see in loops, in addition to how to read data from a file. We'll do the file reading first, and then we'll add in the processing. To read from a file, we need a variable that will reference the file, which I call a file reference variable. This variable is a liaison between our program and the operating system, allowing us to see into the file and obtain its values. We'll need to know the file name. If the file weren't in the same directory, we would use the file path, the path through folders from our script to the file. But we're going to keep this simple and have the text file in the directory with our script and use the file name. I will annotate variables for these two values, file name of type string and file of type text.io. In order to annotate that variable, we're going to have to add another line of code at the top of the script under the docstring. From typing, import text.io. The typing library gives us some variable annotations that allow us to write clearer Python code. Now, finally, we'll need a variable to hold the next value that we have read from the file. When we open a file for reading, the file reference variable will point to the first value in the file. In our file, that's the value 73,802.305. Once we read from it, the file reference variable will advance to the next value in the file, 76,903.805. Each time we read, the file reference variable advances to the next value in the file until it's referencing a special value, the end of file marker. That's a sentinel value that tells us we've reached the end of the file. As we read, we'll usually want to store the value that we've read in a variable so we can process it. This variable will always hold the value most recently read from the file, as we read from the file in a loop. Because a file's values are always text, we're going to declare a variable line of type str. But because our values are floats represented in text, we'll also have a float variable, power usage. We'll convert our lines to floats so that we'll be able to process them as numbers in the next iteration of this program. Okay, so first we'll get the file name from the user, and then we'll open the file. File name equals input, what is the name of the file? And on the next line, file equals open, file name. That will open our file in the default mode, read mode. The variable file now points to the top of the file. This is assuming, of course, that the file exists. We're not going to talk about situations in which the file doesn't exist in this video. I do have other videos on file reading and guarding against errors, such as file not found, when reading from a file, so drop a comment below if you'd like more information on that, and I'll link you to the correct videos. One common mistake I see is learners mixing up the file name with the file reference variable. The file name is text. Think about how you can click on a file name in the desktop and edit it. It's text. In our program, it's a string. The file reference variable is what we get back from the open function, and that allows us to see into the file with our program. Let's read the first line of the file with line equals file.readline. Remember, that returns the next line in the file and advances the file variable to point to the next line. Here is how we'll structure our loop. While line is not equal to open quote, close quote, colon. That open quote, close quote means the end of file. Once we reach the end of the file, readline returns an empty string. So while we haven't got an empty string, let's convert what we have to a float. So indented power usage equals float line, and then let's just print it for now, print power usage. And then let's read the next line from the file, line equals file.readline. After the loop, we should close the file. That line is file.close. And I'm going to throw a comment over each block of code, get the file name from the user and open the file, read and print each line of the file, and close the file. If I run this program, you can see it prints all of the values that are in the file. We have our standard while loop components here. Our loop control variable is line. Our initializer is when it gets its initial value, line equals file.readline. We test that it's not end of file, and if it isn't, we go into the loop, process it, and then the updater at the end of the loop gives it a new value by reading the next line from the file. Files are finite, so this loop will end when we've reached the end of the file. Now, where we're converting our value to a float and printing it, we could do the additional processing of adding it to a total, finding the largest and smallest, and incrementing a count. We'll need new variables for each of those tasks, so I will annotate total, a float, to hold the total of the values in the file, and I'll initialize that to 0. Then count an int, and I'll initialize that to 0. That will always hold the number of values we've read from the file. Max usage, a float, which will be the maximum usage value we've read so far in the file. I'll initialize that to -1, as all of the usage values are positive, and min usage, a float, which will be the minimum usage value we've read so far in the file. The maximum value in the data is under 700,000, so I'm going to initialize that to 1 million. Now inside the loop, after we convert line to a float and store the result in the variable power usage, we'll do our processing. Let's start with adding our value to the total. I'll put a comment, add the current value to the total, and then the code, total plus equals power usage. This line of code uses an augmented assignment statement. It's equivalent to total equals total plus power usage. So it adds whatever is in power usage to whatever is already in total and stores the result back in total. There are augmented assignment statements for plus, minus, division, multiplication, flooring division, exponentiation, and mod, among others. We're going to use the total in conjunction with a count of the number of values in the file. So let's increment that count next with increment the count of values read, count plus equals 1. Now, to check for minimum and maximum, we simply compare the current value we've read, power usage, to the min usage and max usage variables, and replace them if the current power usage variable is a better fit. So for a comment, check if this value is the minimum or maximum so far. And then for the maximum, if power usage is greater than max usage, max usage equals power usage. For the minimum, if power usage is less than min usage, min usage equals power usage. At the end of the program, before or after closing the file, we'll display the average, min, and max to the user. Let's do that only if there were values in the file, since we don't want to divide by 0. So for a comment, display the average, min, and max usage values, and then if count is not equal to 0, indented, print, the average usage is open curly brace total divided by count, colon, 0.3f, close curly brace, and print the max usage is open curly brace max usage, close curly brace, and print the min usage is open curly brace min usage, close curly brace. You can use the same algorithms to total or find a value with a desired property, whether you're reading values from a file or getting them from the user in the console. Now let's read all of the values into a data structure called a list. A list is a data structure that allows us to hold multiple values. The values are stored in order, and each value has an index, a number indicating its position in the order. We have one name to reference the list, but we can access each value by using the list name and the values index. I'm going to rename our program energylist.py. And instead of using the readLine method to read from the file, I'm going to use the readLines method. This will return a list, where each value in the list is the next line of the file. So instead of having a variable called line, I'm going to have a variable called lines, and the type is going to be list, open square bracket, str, close square bracket. That means a list of strings. Remember, the values in the file are text. The readLines method will read each line as text into our list. It will be our job to convert the values to floats if we want to process them as floats. So I'm going to change my comment to read the lines from the file and close it, and then write line equal file.readlines. I can immediately close the file after this, so I'll move file.close up here under readlines. And I'm going to comment out the rest of the program and run this so we can look at lines in the shell. I'll type lines. You can see that the values from our file are strings. They're enclosed in quotes. They're separated by commas, and the list begins and ends with square brackets. That is how a list is defined: open square bracket, a comma delimited list of any kind of value, and then close square bracket. If I want the first value in the list, I will write lines, open square bracket, 0, close square bracket. We read that as lines sub 0. Lists begin indexing at 0, so 0 is always the index of the first element in the list. And you can see that the shell evaluated that to open quote 73802.305/n close quote. That \n at the end is an escape sequence that means new line. In the file, each line ends with an invisible character called a new line. That is inserted when we press enter, and text editors bring the text that's after a new line down to the next line when they display it to you. We can find out how long our list is by using the len function. I'll type len lines and press enter. The shell tells me 60. That means the index of the last value in our list is 59. The index of the last value in a list is always the length of the list minus 1. Now, let's go back to our program and redo our processing, but this time using the list rather than reading from the file value by value. Lists and loops go together like peanut butter and jelly. Let's keep our while loop. Instead of looping over the line, we'll loop over the indices of the list. Our list indices run from 0, the index of the first element, through len lines minus 1, the index of the last element. I'll add a variable to my annotations called I, a very common variable name for looping over an indexed structure, and I'll give it an initial value of 0. That's our initializer. I'll change the while loop header to while I is less than len lines. And inside, I'll set power usage equal to float lines sub I. Lines sub I will be the next element in the lines list. The first time through the loop, it will be lines sub 0. Now, to make sure it's lines sub 1 the next time through, and lines sub 2 the time after that, I'll change my updater to I plus equals 1. This pattern, I starting at 0, incrementing by 1 at the end of the loop, and testing for I less than the length of the list, will always give us each index into the list, one at a time, in order for each iteration of the loop. Let's run it, and the output of the program is exactly the same as before. Lists are a dynamic data structure in that they can grow and shrink while your program is running, and there are a lot of useful methods that are part of the list data structure. I'm going to create a small list here in the console to demonstrate. Numbers equals open square bracket 1, 2, 3, close square bracket. You can add to the end of a list using append. So numbers.append 10, and now I'll type numbers, and numbers is now 1, 2, 3, 10. I can remove a value using remove. Numbers.remove 2, and then numbers, and now my list is 1, 3, 10. I can find out if a value is in a list using the in operator. So 3 in numbers evaluates to true, whereas 2 in numbers evaluates to false. You'll want to check that before you try to remove a value from a list, because if it's not there, you'll get an error. You can also slice a list, which creates a new list from part of a list. I'm going to slice the lines list because it's longer. As a reminder, here's lines. Now let's take the first 4 values. That looks like first 4 equals lines, open square bracket, 0, 4, close square bracket. Let's look at first 4 now. You can see it consists of the first 4 values of lines. The slicing values are start and stop, where Python will give you the values in the list starting with start, up to but not including the value at index stop. So I did not get the value at index 4. I got the values at indices 0, 1, 2, and 3. One important thing to understand about lists that distinguish them from integers, floats, strings, and booleans is that if you pass a list to a function as an argument, the function will be able to change your list. That is not true of the other data types. If you pass an integer, float, string, or boolean variable to a function, the value is copied into the formal parameter variable. However, if you pass a list variable to a function, the function will have access to your original list, and any changes that the function makes to the list will be permanent. It's therefore good to know that you can copy a list with the copy method. For example, if I type numbers2 equals numbers.copy and look at both lists, they both have the same values in them. But if I assign a new value to numbers2 sub 0, such as 200, then numbers2 is changed, but numbers is not. However, if I try to copy a list using an assignment statement, numbers3 equals numbers, then I have not copied the list. I have 2 variables referencing the same list. This is the same situation as passing a list as a parameter. If I now set numbers3 sub 0 equals 300, the 0th element is now 300 for both numbers3 and numbers. Lists are a kind of iterable, which means we can use a for loop to visit each element in a list. I'm going to rename this program as energy iterable1.py, and we'll look at iterating over the list using a for loop. I'm going to change our loop header to for_line inlines, and I'll annotate a variable line as a string, and I'll remove all references to I. So I'll delete the updater at the end of the loop, and I'll change the line that converts a line to a float to power usage equals float line. A for loop doesn't need us to maintain a loop control variable for it by initializing and updating it, because it's not a conditional loop. It's a loop that will iterate over every element in an iterable. A list is an iterable. When we write for_line in lines, our loop control variable, line, will take on each value in the list lines once for each iteration of the loop. So the first time through the loop, line will be the string 73802.305/n, and the next time through the loop it will be 76903.805/n, etc., until it takes on the final value in the list, 76799.57/n, and after the loop body executes with that value in line, the loop finishes execution. We won't have an infinite loop. And if I run that, we get the same output. So that is a very nice way to loop over a list, provided you don't need to modify the list or access the indices of the list for some other reason, such as looping over parallel lists. I'm going to show you how to loop over the indices of a list using a for loop and another kind of iterable called a range. I'll call this version of the program energy iterable2.py. And I'm going to need my I variable back, but I don't need to give it an initial value because the for loop will take care of that. So I'll delete line and write I int. Now my loop header is going to be for I in range, open paren, len, open paren, lines, close paren, colon. And I'll go back to power usage equals float lines sub I. And again, if I run it, I get the same output. Now this time the iterable is a range, which generates a series of values for me. And the values I want are the indices into the list. Let's look at range in the shell. I'm going to wrap list around each of my range calls because otherwise you won't be able to see the values it generates. Let's start with list range 10. Notice that generated the values from 0 through 9 in increments of 1. And those would be the indices of a list with 10 elements. So if we pass a number to range, it gives us from 0 up to but not including the value we pass in, exactly the indices of a list of that length. In our program, we're passing len lines into range, which is the length of our list, so that will generate the values from 0 through 59. exactly the indices into our list. This pattern will always give us the indices into a list. And we'll want to loop this way again if we need to get into our list to change it, among other reasons. Another kind of iterable is a string. If I write in the console, for char in hello world, print char, the console prints each character in that string one to a line. The for loop is very handy in Python for iterating over a collection type like a list or a string, and also for iterating over a pattern of numbers if you use a range. You can generate more complex ranges by passing in a starting value, a stopping value, and a step, or increment. So for example, if I type list range 10, 101, 5, I get the values from 10 through 100, up to but not including 101, in increments of 5. This file processing program with a loop and a list is the conclusion of our Introductory Python refresher. Whether you're a student moving on to your next course or an experienced programmer who needed a refresher, I hope this review helps you and gives you some confidence with the Introductory Python material. I have detailed videos on all of the topics that I covered here and more, so please look at the Introductory Python playlist if you want to take a deeper dive into specific topics. Put a comment below if you can't find what you're looking for. There are programming exercises in the description for all of these examples, so you can practice, and the code for these examples is in my GitHub repository. There's a link to that in the description. As always, have fun and keep coding.